All right, welcome to the deep dive. Today we're looking at something that just feels right, like getting kids moving is good for their brains. Makes
Yeah,
sense, right?
intuitively.
We're diving deep into the research on exercise and its effects on how kids think, learn, and perform in school.
Really interesting area.
It's a concept with a long history, even going back to ancient Greece. But what's the actual scientific evidence telling us?
That's a great question. We dug into a pretty comprehensive review of studies
Oh, wow.
that have really looked closely at this relationship between exercise and what happens in children's minds.
Hmm.
And we're talking about three key areas: intelligence, those cognitive skills,
Hmm.
things like attention and memory, and then how well they actually do in school, their academic achievement. So we wanted to kind of cut through all the noise and bring you the most important, clearest findings.
Yeah, and that's our mission for you, the learner. We want to extract the key insights without overwhelming you with too much data. We're aiming for that clear picture of how physical activity actually shapes young minds.
Yeah, absolutely.
And you know what I found fascinating?
What's that?
There was a bit of a decline in this research in the 70s and 80s. It seems the emphasis back then was primarily on the physical benefits of exercise.
You're absolutely right. Back then, the focus in education was a lot on physical health and, things like preventing obesity.
Right.
It wasn't really until the health and wellness movement and the field of exercise psychology really gained momentum that we saw this renewed interest in the potential mental benefits of exercise. So while the idea has always been around,
Mhm.
this detailed research, it's really a more recent development.
Okay, so let's delve into what seems to be a central idea in all this, the executive function hypothesis. Sounds a bit academic,
Yeah.
but the concept itself is actually quite intriguing. So what exactly do we mean when we talk about executive functions?
Well, you can think of executive functions as kind of the control center of your brain.
Okay.
They're the mental processes that we use to plan, organize, and initiate actions that are goal-directed.
So it's kind of like, if you imagine your brain as an orchestra,
Yes.
the executive functions are like the conductor, making sure all the different instruments, our attention, our memory, are all playing together to achieve that goal.
Yeah, that's a
Yeah.
perfect analogy.
Okay.
And what's really interesting is that research with adults has already shown that aerobic exercise can really benefit executive function. Like, for example, there's this great review by Colcomb and Kramer back in 2003, and they found that exercise actually had a pretty significant positive effect on the executive functions of older adults. So that naturally led researchers to think, well, what if this applies to kids as well?
Makes sense. If it helps older brains, it might be even more important for those developing brains. So based on that research with adults, what are the key components of executive function that have been identified?
Well, mostly building on a model proposed by Miyake and his colleagues around the year 2000, there are three main components, and they are interconnected. So first we have set shifting, and that's basically your brain's ability to shift gears, so to speak, to move between different tasks or different thought patterns. Then there's updating. That's very closely tied to your working memory. It's about keeping track of new information and then revising what's in your mind.
Okay.
And finally, there's inhibition, which is our ability to resist impulses or ignore distractions.
Those sound incredibly important for learning, both in school and just in everyday life. So how does all of this relate to what's happening in a child's developing brain? Like, what's the neurological basis for this theory in kids?
Well, that's where it gets really fascinating. We know childhood and adolescence are just these periods of really intense brain development. You see a huge increase in gray matter early on, followed by a refining process in the frontal part of the brain, that's the frontal cortex, and this significant increase in myelination. Now, you can think of myelination like adding insulation to the wires in your brain. It helps those signals travel more efficiently. And that process continues into early adulthood. There was this amazing work by Diamond in 2002 that really showed how these physical changes in the brain actually coincide with improvements in things like how fast kids can process information, how well they can use strategies, their working memory capacity, and their ability to control their responses.
So it's not just about the brain getting bigger, it's about the brain getting more organized and efficient over time.
That's exactly it. And here's the exciting part. It seems exercise actually influences that neurological development.
Wow.
Research has shown that being physically active can stimulate the production of neurotrophins, which are basically like brain food.
Brain food.
They help brain cells survive and grow. Exercise also supports synaptogenesis, which is the formation of those connections between brain cells,
Okay.
and angiogenesis, which is the growth of new blood vessels, more blood vessels meaning more energy and oxygen supply to the brain.
Yeah.
Studies by Nelson, Barday, Vaneman, and Gomez-Pinilla, Huttenlocher, and Black, all these researchers have helped us understand these mechanisms.
So exercise is not just about building muscles. It's actually like going in and affecting the structure of the developing brain.
Yeah, it really is. And the impact of having well-developed executive functions in children goes far beyond just their grades. The review highlighted that difficulties with executive function have been linked to conditions like ADHD and autism. Research by Leon and Naglieri has shown that. And we know from the work of St. Clair Thompson and Gathercole that strong executive function skills are really important for how well kids engage in the classroom and succeed academically.
So it sounds like these skills are really the foundation for so much of a child's experience.
Yes, absolutely. And research by Barkley suggests that executive functions are also crucial for things like developing imagination, empathy, creativity, and even a child's ability to reflect on their own performance and learn from their mistakes. So it really has a broad impact on their psychological and social growth.
Okay, so the theory is compelling, but what does the research on exercise and children's intelligence actually tell us? Let's start with those early studies that used IQ tests.
Yeah. The review looks at some of the first studies from the 60s that used these standardized intelligence tests. For instance, the WISC, to see if exercise had any effect. There's this one study by Corder in 1966. It involved boys with moderate intellectual disabilities,
Okay.
and it showed some improvement in their IQ scores after a 20-day fitness program.
Oh, wow.
But there was a control group, and they also showed similar gains. So the researchers thought maybe it wasn't just the exercise, maybe it was just the extra attention these kids were getting.
It can be hard to isolate the exact cause of these changes in studies.
That's right. And then there was another study by Brown in 1967, also with boys who had lower IQ scores, and they found improvements on the Stanford Binet test and a measure of social maturity after a 6-week program of isometric exercises. Now, those are the exercises where you tense your muscles without moving.
Okay.
And Brown suggested that it might have been the mental concentration needed to hold those poses that actually contributed to the improvements.
That's interesting that even physical exercise can have this mental component that might lead to cognitive benefits.
Right. But these early studies, they were often pretty small, and the children involved had specific intellectual profiles. So it's hard to say if those findings would apply more broadly. And then there's this much larger study by Ismail in 1967, which followed 5th and 6th graders for a whole school year. And surprisingly, it found no significant effect of this enhanced physical activity program on their IQ scores, measured using the Otis IQ test.
That seems like a pretty big finding, given the scale of the study.
It is. And the study was strong in its size and duration. However, the review pointed out that it didn't provide a lot of specifics about the intensity of the exercise, either in the enhanced program or in the regular PE classes. So we can't really be sure if the exercise was vigorous enough to cause those cognitive changes.
Okay, so looking at these early IQ studies, what's the main takeaway?
Well, the authors of the review suggest that the limited findings might be because IQ tests, or these global intelligence tests, they're very broad measures. They might not be sensitive enough to detect those specific changes in cognition that exercise might be influencing.
That makes sense. So maybe we need to look at studies that use more targeted measures of cognitive function,
Exactly.
which leads us to the research on exercise and specific cognitive processes. So what did those studies reveal?
Well, that's where we start to see more compelling evidence. There's this 2005 cross-sectional study by Hellman and his colleagues, and they compared children and young adults with different fitness levels. They found that fitter children had faster reaction times, and the patterns in their brain activity, which were measured with EEG, suggested faster processing and better attention during this visual task. What's interesting is those brain patterns in the fitter kids were similar to what they observed in fitter adults,
Oh, wow.
which kind of points to this potential link between fitness and brain efficiency across age groups.
So even just being more physically fit is associated with these cognitive advantages.
Precisely. And then there's a 1991 study by Zervas and colleagues, and they looked at twins to examine those immediate effects of exercise. And they found that a single session of exercise improved how quickly and accurately these kids performed on a design-matching task. And that was true even regardless of whether they had been in a longer-term aerobic training program or just in the regular PE classes. However, that longer-term training, it didn't seem to give them a pre-exercise advantage on this particular task.
So it's like a quick burst of exercise can give you a temporary cognitive boost, but the sustained training, the effects on that skill weren't as clear.
Yeah, good summary. The immediate kind of alertness and focus that you get from exercise probably plays a role in that temporary improvement. Then you have studies on creativity by Tuckman and Hinkle in '86, and Hinkle and colleagues again in '93, where they looked at the impact of aerobic running programs on elementary and middle school children. And they found that these programs actually boosted the kids' performance on creativity tests, like the alternate uses test and the Torrance test of creative thinking. But interestingly, they didn't see much impact on more general cognitive skills.
That's fascinating. So it's like exercise might have this targeted benefit for thinking outside the box skills?
Yeah, seems that way.
And the review mentions that creativity is actually linked to executive function, right?
You got it. A lot of researchers in cognitive psychology see these creativity tests as tapping into different aspects of executive function. How easily you can come up with ideas, that's fluency, how varied those ideas are, flexibility, and how original they are. So it really supports that idea that exercise can help executive functions.
Okay. What about studies that directly measure executive function and look at the effects of exercise in children?
Like 2007 randomized controlled trial by Davis and colleagues really provides some of the strongest evidence.
Okay.
They focus on overweight children and found that 10 to 15 weeks of moderate to vigorous exercise for 40 minutes significantly improved their scores on the planning scale of the CAS. That's the Cognitive Assessment System.
Okay.
It's a measure of executive function. What's interesting is when those kids exercise for a shorter time, just 20 minutes, they didn't see the same effect.
So it suggests there might be a certain threshold, either in duration or intensity, to really see those benefits for executive function in kids.
That's a key takeaway. It shows that not all physical activity is the same when it comes to its effects on cognitive skills.
Right. Okay, so we've explored intelligence and specific cognitive processes.
Yeah.
Now let's turn to what's often a top concern for educators and parents, academic achievement.
Right.
What does the research tell us about the link between exercise and how well kids do in school?
Well, this is where a lot of research has been done. But the findings are, well, they're a bit more mixed.
Uh-huh.
We see a number of correlational studies showing a positive link between physical fitness and academic achievement.
Okay.
Like large-scale studies by Dwyer and colleagues in Australia, reports from the California Department of Education, and research by Castelli and his team.
Wow.
They all found that children who are more physically fit tend to do better on those standardized tests and get better ratings from their teachers. Castelli's study, specifically, linked aerobic fitness to better performance in reading, math, and overall academic achievement.
Those large-scale correlations sound pretty convincing.
Yeah, they do suggest a relationship, but it's super important to remember that correlation doesn't equal causation. Just because two things happen together doesn't mean one causes the other. And not all correlational studies show the same thing. Like, for example, a study by Tremblay and colleagues in 2000 found no link between self-reported physical activity in sixth graders and their academic achievement.
And self-reporting can be a bit iffy when it comes to kids accurately describing their activity levels.
Yeah, exactly. That highlights a potential problem in some of the research. Now, when we look at longitudinal studies, which track the same kids over time, the picture's still a bit unclear. The Three Rivers Project by Shepard and colleagues found that kids who were in a really intensive program, getting 5 hours of activity a week, had better grades from 2nd to 6th grade, compared to a control group that only had 40 minutes of PE a week.
That's a huge difference in outcomes.
It is. But then the South Australian project by Dwyer and colleagues, they found that increasing physical activity led to better fitness, but no real difference in standardized test scores for math and reading. But their take on this was interesting. They pointed out that reducing academic time for more physical activity didn't actually harm academic performance.
So it's not a trade-off.
It seems like it might not be.
More physical activity, but we're not sacrificing the academics.
Right. And the Spark Project by Salas and colleagues, they also found that a physical activity program didn't negatively affect academic achievement. In fact, the scores declined less in the groups that got the program compared to the control group. But it's worth noting, those kids were from higher socioeconomic background, so it might not apply universally.
Okay. And what about those experimental studies where researchers actually manipulate the exercise kids get?
Right. The 67 study by Ismail, the one with the IQ tests, actually found that the Enhanced Physical Activity Program did help the children on the Stanford Achievement Test. And the benefits were across the board, regardless of their initial achievement levels. But a newer study by Coe and colleagues in 2006, they found no big difference in grades or Terra Nova scores between kids with different amounts of PE. However, those who reported more vigorous activity outside of school had higher grades, suggesting maybe it's the intensity and consistency outside structured PE that matters.
So it sounds like the relationship between exercise and academics is much more nuanced than the link with executive function.
That's a fair assessment. The review stresses that many of the studies on achievement haven't used the best research designs, like random assignment, and they often rely on teacher grades, which can be biased.
Right.
The safest conclusion is that physical activity doesn't seem to hurt academic progress, and might even help in certain situations.
So given this overview, why have the findings been so inconsistent? What are some of the key reasons? The review does mention some factors, right?
Yeah, absolutely. One big reason is the variety of tests used. Like we said, those global IQ tests might just not be sensitive enough to pick up those specific cognitive changes that exercise could be causing. Using more focused assessments, especially those looking at executive function, seems to give more consistent positive results.
Okay, that makes sense. And then the type of exercise probably matters too, right?
For sure. The review highlights that different types of training could have different effects on the brain, whether it's aerobic exercise like running, or resistance training, or activities focused on motor skills. In general, the studies showing the most promise, especially for executive function, have involved vigorous aerobic exercise programs.
And the kids themselves, their age, fitness levels, and any pre-existing conditions could influence the outcomes as well.
Right. The kids in these studies are very diverse. For example, some early research focused on kids with intellectual disabilities and showed some potential benefits. And Davis's study was specifically on overweight children and found improvements in executive function. It's also likely that sociocultural factors, like family support for being active, could play a role in how much kids engage and how they might benefit.
And age seems super important.
Yeah,
A 5-year-old's brain is developing so rapidly.
you're right.
How might that brain respond to exercise differently than a teenager's brain?
Age is definitely a critical factor because so much is changing. Those neural pathways, motor skills, cognitive abilities, social development, they're all unfolding at different rates. Like the ability to control impulses might mature earlier in childhood compared to complex planning skills, which keep developing into adolescence. So an exercise program might be great for improving inhibitory control in preschoolers, but not have the same impact on planning skills in older kids.
Okay.
And the complexity of movements in an exercise could challenge different age groups in different ways. And whether a child is exercising alone or in a group, that can have different effects depending on their age.
It sounds like a lot of factors to consider.
It really is.
So what do the authors of the review suggest for future research? What needs to be done next?
They really emphasize the need for more systematic research that looks closely at all these different aspects of exercise. The amount, the type of activity, even the learning environment where it takes place. They also stress using cognitive tests that are right for the age of the kids and are sensitive enough to detect those specific changes that exercise might be causing. And considering the characteristics of the children, including developmental conditions, weight status, sociocultural background, basically they're calling for research that builds a comprehensive model of how exercise influences cognition in children, taking everything into account.
So bringing it all together, what's the main takeaway for you, the learner, from this deep dive into the research?
The key takeaway is that the research really suggests that exercise, particularly vigorous aerobic activity, can positively impact specific aspects of children's mental functioning, especially those executive functions, planning, creative thinking. The link between exercise and overall intelligence or academic achievement is still being explored, but the evidence so far suggests that physical activity doesn't hurt academics and might even have cognitive benefits.
So encouraging kids to be active isn't just about physical health. It could be a really valuable way to support their cognitive growth, those fundamental areas that are so critical for learning.
Exactly. And that leads to a really important question for you to consider. Given these findings, how can we design educational settings and family life to better utilize the potential cognitive benefits of physical activity?
Mhm.
What does this mean for recess, PE classes, after-school activities?
Food for thought. Something to ponder.
Yeah, definitely.
Thanks for joining us on the deep dive.
Thanks for having me.